Energy portfolio analysis. While we provide an overview of various energy efficient technologies, this course will focus on data handling, how to organize and manage energy data in Excel, analysis techniques, how to use Excel functions and formulas to analyze energy consumption and savings, visualization, creating charts and graphs to visualize energy data and insights. For more in-depth information on these technologies, there are plenty of resources available online. LED lighting replacement for small commercial facilities. Overview. LED lighting is a highly efficient and long-lasting lighting solution. It consumes significantly less energy compared to traditional incandescent or fluorescent lights. Benefits: energy savings, up to 75 to 80% reduction in energy usage. Long lifespan, LEDs last significantly longer, reducing replacement costs. Improved lighting quality, brighter and more consistent light output, enhancing the working environment. Example, a small retail store upgrades lighting system to LEDs, reducing its annual energy consumption by 60% and saving around $3,000 per year in electricity bills. Boiler replacement with condensing boiler. Condensing boilers are more efficient than traditional non-condensing boilers as they capture and reuse heat from exhaust gas. Increased efficiency, up to 95% efficiency compared to 70 to 80% for non-condensing boilers. Energy savings, significant reductions in fuel consumption. Environmental impact, lower greenhouse gas emissions. Example, a small office building replaces its old boiler with a condensing boiler, reducing its annual fuel usage by 25% and saving around $2,500 per year. Insulation upgrades for energy efficiency. Improving insulation helps maintain indoor temperatures, reducing the need for heating and cooling. Benefits: energy savings, reduced heating and cooling costs, comfort, more consistent indoor temperatures. Environmental impact, lower energy consumption, reduces carbon dioxide emissions. Example, a small clinic improved its insulation, cutting its heating and cooling costs by 20% and saving about $1,500 annually. Solar panels. Solar panels convert sunlight into electricity, providing a renewable energy source. Benefits: energy independence, reduces reliance on grid electricity. Cost savings, significant reductions in electricity bills. Environmental impact, zero emissions from solar power. Example, a small restaurant installed solar panels, generating 50% of its annual electricity needs and saving approximately $4,000 per year. Tankless water heater. Tankless water heaters provide hot water on demand, avoiding the standby energy losses of traditional water heaters. Benefits: up to 30% more efficient than traditional tank heaters. Compact size frees up space, typically longer lifespan than tank heaters. A small cafe installed a tankless water heater, reducing its annual energy costs by $800 and freeing up storage space. That is an example. Next, I'm going to demonstrate energy portfolio analysis using Excel. Okay, so here we have a data set for 10 bank branches of Bank X, including project costs and GHG reductions for the different energy efficient technologies. Here we see an example of 5 different technologies: LED lighting, boiler replacement, insulation improvements, solar panels, and tankless water heater. I already gave you a brief overview of each technology. We are going to see in more details on how to calculate the energy savings for each technology, but for now, let's focus on this scenario that you have 5 different projects for each branch of the bank, starting from the first branch to 10 branch. So for each branch, we are considering these 5 different projects. For branch 9, 5 different projects. For branch 8, 5 different projects. For all of these branches, we are considering 5 different projects. But we are not going to select all the projects for all the branches. We are going to select it based on strict criteria. Let's say if the dollar per ton is only less than 6,000 and the benefit cost ratio is greater than 2. If they meet both these criteria, then only we are going to select it. Just meeting one criteria or not meeting is not good. So for the first one, since it has to meet both criteria, let's use a combination of if and statement. If. Why we are using and? Because it has to meet both criteria. This one per ton needs to be less than 6,000. And for 6,000, let's absolute reference it because this is the reference value. We are always going to use it. We are not going to change it according to the cell, but it's going to be fixed 6,000. It's only if this projects meet this criteria is less than 6,000, we are going to select it. So I absolute referenced it. Again, for this one, actually it's hiding. It's in cell G13. So let's just type here G13 because we cannot select it, it's hiding. G13 needs to be greater than the benefit cost ratio of 2, and this 2 is a fixed amount. So let's absolute reference it by clicking F4 and then just type yes. It means we want to select the project if it meets both criteria, otherwise no. So once you're done with that, just double click here and it will autofill the rest. So see, each of these cells is referencing to the right dollar per ton and this year, but is keeping these values fixed. So after we are done with that, if you're interested to see which projects meet the criteria, both criteria, just go to filter and select yes. And you see here count 17 means 17 projects meet the criteria. How many projects were there initially? There were 10 branches and 5 projects for each, means there were 50 projects, and out of 50 projects, 17 passed the criteria. Just go to here and clear the filter if you want to clear the filter and see again everything, but you don't want to remove the filter. But if you want to remove the filter, just click on filter again. So here we want to see what is the minimum benefit cost ratio out of the projects which only passed. So the condition here is that if the projects pass the both of the criteria, only then we want to find the minimum benefit cost ratio. For the ones which are no, we just ignore it. So let's do that. Minimum, we will use a combination of minimum and if. It's a bit tricky. And if column H is equal to yes, only then consider the minimum, otherwise no. So now, since so the if statement says only if it passes the minimum condition, then select this one. We want the minimum of that number of that column of benefit cost ratio. Actually, it's supposed to be first the if statement, and then oh. Equal to minimum is going to be a combination of minimum and if statement, because only if it passes, we are going to consider the minimum. We want to see the minimum value of the benefit cost ratio. So what is the if statement? If the projects pass the criteria, if HH equal to yes, only then do the minimum of benefit cost ratio. Possible. So once we are done with the minimum, we are going to copy the same formula here and put it here. But this is max, right? So after copying, just change from min to max. And then we are going to do the same thing, but instead of max, we are going to find the average. So if you just filter the projects which are yes, check the minimum here benefit cost ratio. The minimum is average is 3.47, minimum 3, max 4. Oh, that's hiding the minimum, max is 4, so that's matching. Average is 3.47. Let's check the minimum. Minimum is 3, so that is correct. Do the same for, so again, I mean, this is the trick. Copy the formula and put it here, and click on the formula to check which cell or columns it's referencing to. But this time we want the dollar per ton, so simply uh, catch this BCR column and then drag it to dollar per ton. So it gives you now the minimum dollar per ton only for projects which are yes. So do the same thing, copy and paste it here, but instead of min, do the max. And then finally do the average. So for number of projects, we are going to see how many pass the test. So just do count if. So what does count if does? This formula count if, count the projects based on certain criteria. So the range is this one, only if it's yes. So count if the column, only if it says yes, then count the projects which are yes and meet both criteria, which is 17 again. Total greenhouse gas reduction. So we want to sum if first criteria or argument they're looking for is the range, and then the criteria which is going to follow to for this range, which criteria it has to follow. So first range is this one, and it has to follow which criteria? It has to follow the yes criteria. Make sure you make the capital Y, otherwise it's Excel, right? It doesn't understand the difference between capital Y and lowercase y, so we need to type in the exact thing here. Careful. So the sum range is going to be the sum of annual greenhouse gas reduction. And here you go, 118.9 means only. So let's just check. Only if you select the projects which are yes, is it total greenhouse gas reduction 118.9? This is a cross check. So see, the sum here is 118.9, which means this is true. So the total project cost, similar fashion, but just again, copy and paste the formula. Go to the formula, click here and see. This is now referencing to this one, but you want to just hold it and drag it to the project cost, because now we are looking for the total project cost. Once you are done with that, you can easily calculate the overall dollar per ton, which is the total project cost divided by the greenhouse gas reduction tons. This is the overall dollar per ton, means you take the total project cost and total greenhouse gas reductions and find the ratio. Means for each ton of greenhouse gas reduction for the whole portfolio, you need to spend $3,976 for these 17 projects. Okay, so let's see the second scenario. This time our criteria will be easier for the projects to pass, because it will be less strict than before. So remember, before we had to make sure that the projects pass both criteria. This time I will just set the formula in such a way that if the projects pass just one of the criteria, it is good enough. So it's easier for the projects to pass. So most probably, although I mean it's not always going to happen, most probably we'll get more projects, but let's see. So instead of using and, actually this is a trick to save your time. Once you develop the formula, when you are working for real projects, you don't need to always, I mean, recreate the formulas from the scratch or from beginning. Just copy it and paste it here. But this time, instead of and, we are going to use or. Means if it just passes one of the criteria of dollar per ton or benefit cost ratio is good enough. So this is the trick. Just copy it, paste it, and change the formula from and to or. And then autofill, filter. Let's see how many projects pass the criteria. It's actually 21. Before it was 17, now it's 21, which makes sense because this time we relaxed some of the criteria. It's not really relaxing. It's more of like if it just passes one of the criteria, it's good enough. So obviously we have now more projects. So let's do the mean and max again. Again, since we already developed the formula, this is the trick to save your time. Just copy and paste. But when you copy and paste, this is extremely important. You make sure that's referencing to the right cells. So we just go there and click it here and see if this criteria passes, then find the minimum of the benefit cost ratio is pointing to the right columns, which is correct. This one, this is also correct. This is also correct. But this time, these values will not be the same as the first one. Why? Because these ones are for the projects which pass both criteria. Means this one are the projects which pass just one of the criteria. So obviously the mean, max, and average is a bit different. Although it might be the same depending on what is the portfolio like. So let's finish the rest. Copy and paste there. And again, just like I told you, when you copy and paste from one worksheet to another to save your time, because it's referencing to the, or it's using the same kind of formulas for same kind of tables, just click on the formulas and make sure it's referencing to the right columns, because things might be more like things might be in different locations here, so they are going to point to different columns. If you don't make sure, you are going to make a mistake, because if it, let's say if the column was here, then it's a mistake, because this is not really, I mean, it might not be placed in the same location as in the first scenario. So always make sure by clicking to see if it's referencing to the right columns. Next, this one, yeah, it's dollar per ton, because this is dollar per ton. This one is again averaging the dollar per ton based on this criteria. So that is also selecting the right columns. So let's copy this and paste it here. Total number of projects 21. We already counted it manually. Annual greenhouse gas reduction based on the criteria is taking this column, which is okay. And again, total project cost is this one. So overall dollar per ton this time is total project cost divided by the total greenhouse reduction for 21 projects. And for each ton, you are going to spend this much money. So when it's overall dollar per ton, it's actually considering the whole portfolio. So which is 2,582. Let's do a quick check to see which one is better. So see, I mean, if you are really strict about the projects, it has to pass both criteria. Then to reduce 1 ton, you need to spend around $4,000 here, whereas here is around $2,500. So this is good in terms of overall dollar per ton. What about total reductions? 172.75, and this is 118. So again, this one is better because saving more greenhouse gas. Total project cost here is 446,000. Here is 470,000. This one is more expensive. One of the reasons might be because we are selecting here more projects. So that's why we are selecting, oh, it's interesting because we are selecting here more projects, still the project cost is lower. So it all depends on the relative project costs. So although we are selecting more projects, we are selecting the projects which has a lower cost. So finally, the summary, selection based on both criteria. So this is the mean. What is the minimum of benefit cost ratio? So just press equal and reference to the right cell, go to the first scenario, and benefit cost ratios. So for this one is selection based on both criteria. This is selection based on dollar per ton and benefit cost ratio. So this is scenario 2 equal to this one. So I think if you just copy and drag, it's going to do the rest. The reason is, since the first one is referencing to this one, when I copy and drag it to the next cell, this one is obviously going to point to this one. If the first one points to this one, the second one will point to this one. So 343.47, see 340. So these are some of the tricks you can use in Excel to save your time. So similarly, selection based on both criteria for dollar per ton, we follow the same technique. Is this one, copy and drag to fill the rest. And this one is pointing to this one. So here we have all the information. Just do a full cross check: 2000, 10,000, 3,000. Yeah, this one is 2,000, 5,000, 4,000. I'm just looking at the rounded figure. So that is correct. So just a quick cross check, because it's easy to make mistakes in Excel. It's pointing to different tables and cells. So I mean, you always want to check. Okay, so let's now create a pivot table based on our portfolio. So to create a pivot table, just first you need to select the data, and we need to paste the pivot table here in this worksheet. So to insert the pivot table, go here, insert, and then pivot table from table and range. So tabular range, it's this one. So let's say I just want to do it up to here. So just select it. And I just want to show the first 9 branches. So I'm not going to the 10, I'm just ending here. So up to B E57 here. And then okay. So next, so what is the purpose of the pivot table? You need to understand. The pivot table is to represent the data here in useful ways, in ways which you can visualize the data so that you can make informed decisions. So because see, it's a huge table. It can be even larger if there are more branches, but you want to see the important information from these tables in a way which will help you to make better decisions. And it's not possible right now because it's a big table and you don't know where the different useful information is hiding. So pivot table will help you with that. Let's see how. So branch technology, project cost, annual greenhouse gas reduction. So we want to see for each branch what are the different technologies and what is the total project cost and annual greenhouse gas reduction. So how to see it? See here the rows. The rows will show the information which you want to put here. So for example, if I put the branch here, let's put the branch here. So branch on top of technology means first you will show the branch and then the technology. So that's why the branch row here, you see here, the branch row is above technology. And then the sum of project cost is here. So for example, for the first branch boiler replacement, it's $20,000 and insulation improvements is $15,000. So it shows all the branch with the related project cost. So let's say here we have what, up to 9 branches, but we want to see all the 10 branches. So how to edit it? Let's say you already make the pivot table and then you want to change the pivot table to represent the bigger table. So how to change it? Just go to select the pivot table, go to data, and actually it's pivot table analyze here, and then change data source. So first go to pivot, so select the pivot table, go to pivot table analyze, and then change data source. And instead of E57 here, we want to actually change it to H62. So here we select the whole thing, select the whole table. So that's why intentionally before I left out branch 10, because I wanted to show you if later you want to change the data source, how to do it. So now it's going to, so see, now it shows all the 10 branches, but if it doesn't show, just go and refresh it and it will show. So let's go to the pivot table and see what are the different ways. So this is one way to represent it. So if let's say if I want to filter it by branch, I don't want to see all the branches. I can filter it by branch. And I'm just interested in selecting branch 1 and 6. I'm not interested in other branches. Maybe other branches are not important for me for many different reasons, but only 1 and 6. So this is now the total project cost for branch 1 and 6. I can see the total project cost for boiler replacement for branch 1 and 6 is $40,000. So let's do a quick check. Is it so? Just to make sure that it is not representing the wrong information. So branch 1 boiler is for boiler, right? So branch 1 boiler is 20,000 and branch 6 boiler is 20,000. So in total, it is 40,000. Yes. Let's do a quick check for the next one. So insulation improvement is 30,000 for branch 1 and 6. Select the insulation improvement cost for branch 1 and then control and select it for branch 6 insulation so that you can select multiple entries. So just press control and select both cells. And you can see the sum is $30,000. Let's make sure it's 30,000. Yeah, so which means it's representing the right data. If you want to see the project cost in dollar, you can just go there and change it to data format of dollars. It will show you the total cost. So there are many different ways you can represent it. But if you want to see the branch 1 and 6 separately, this is how you do it. It's not going to show you the sum. So see, it's showing separately. What if I want to also see the information for branch 10? Just select the entry and it will show all this information. So instead of doing sum of project cost, what if I want to see the average project cost? Let's try it and see how does it change the table. Value field settings. So again, just go to sum of project cost here because this is the values. You can represent it using sum or average. So let's change from sum to average. Go here from sum, select the switch it to average option and OK. So this is the average of project cost. I know that it's going to be the same because for branch 1 boiler replacement is just one cost, right? So for average project cost, it's better to filter it. Because when you filter the branch, it's going to show you the average cost of boiler for all these branches 1, 6, and 10. So let's do a quick check. Go to the main table. So just select this one, project cost for 1, control, hold your control key. And for boiler, for branch 6, this one. And what was the last one? 10, right? So keep so hold the control key and then this one. So let's check the average here is 20,333 average boiler cost for branches 1, 6, and 10. So 20,333 is matching with this one, which means it's representing the right value. So these are the different ways you can use the pivot table to represent the data in a useful way. You can also do, because see, the project cost is average, but the greenhouse gas is sum. You can also change it to average. Or you can change it to other key information. For example, I want to see out of 1, 6, and 10, which one is the maximum for boiler replacement. So the maximum greenhouse gas reduction is 4.2 for boiler replacement. Out of these 3 branches, 1, 6, and 10. But if you want to see all the branches, select all of them, and it's going to show you the maximum greenhouse gas reduction. Let's go here, refresh. Although the value didn't change, but it's actually showing you the maximum. If you want to check, we can go and check. So for boiler replacement only, right? So just filter the boiler replacement here. And for all of them, what is the maximum annual greenhouse gas reduction? Just select all the cells and check here 4.2, which is shown here 4.2. So that is the right information in the pivot table. So this is all about pivot table, but there is more. You can just I recommend that you drag the criteria in different filters, columns, rows, and values, and see how does it affect the presentation of the whole table. So finally, a recap of what we did: project prioritization based on dollar per ton carbon dioxide emissions and benefit cost ratio. So the total budget is $500,000 for year 2024. The technologies overview: LED lighting replacement, boiler replacement with condensing boiler, insulation improvement, solar panels, tankless water heaters. What are our evaluation metrics? A dollar per ton carbon dioxide savings. This measures the initial investment cost per ton of carbon dioxide emissions saved annually. Lower values indicate higher cost effectiveness. Benefit cost ratio, this measures the return on investment. Higher benefit cost ratio values indicate more favorable economic returns.